Welcome to the Chromperfect user training channel. In this video, we are going to look at timed integration events in Chromperfect. Chromperfect has been designed to automate as much of the chromatographic process as possible. For that reason, we generally encourage users to rely on method-based integration tools wherever possible, rather than making repeated manual integration changes to individual chromatograms. Manual integration can be useful for reviewing or correcting a specific result, but timed events allow integration behavior to be built directly into the method file. Once saved, those events can then be applied automatically and consistently whenever that method is used. In this video, we will give a practical introduction to timed events, and then briefly explain the available options in the timed events section. Manual integration and timed events. When you manually adjust a peak start point, stop point, baseline, or split point on a chromatogram, that change applies to the chromatogram you are currently working on. That can be useful when reviewing a single result, but it is not the best approach when the same correction needs to be applied every time the method is used. Timed events are different. They are stored in the method file and are applied automatically during integration. This means that if the same peak behavior occurs regularly, such as a peak starting too early, stopping too late, needing a horizontal baseline, or needing to be split, the preferred approach is usually to add the appropriate timed event to the method. Where timed events are used. Timed events are placed at specific times in the chromatogram. Each event tells Chromperfect to change something about the way the chromatogram is processed or displayed from that point onward, or to perform a specific action at that point. Some events turn a behavior on. Some events turn a behavior off. Some events are single commands that happen at the time where the event is placed. The event list includes a symbol, a short description, and a small graphic showing the effect of the event. This makes the timed event window a useful reference while building or adjusting a method. Integration on and off. The first group of events controls whether integration is active. INT plus turns integration on. INT minus turns integration off. These events are useful when there are parts of the chromatogram that should be ignored during integration. For example, if the early part of a run contains solvent disturbance, injection disturbance, or a region that should not produce integrated peaks, INT minus can be used to turn integration off. INT plus can then be used later in the chromatogram to turn integration back on. This allows the method to focus integration only on the region of the chromatogram that matters. Baseline control. The next group of events controls how Chromperfect places or manages baselines. SBN means Set Baseline Now. This event tells Chromperfect to set the baseline at the exact time where the event is placed. SBN can be useful when the baseline needs to be forced at a specific point, especially where the automatic baseline decision does not match the user's intended integration. SBNV means Set Baseline at Next Valley. This tells Chromperfect to set the baseline at the next valley after the event. This can be useful when the exact valley position may vary slightly between runs, but the method still needs to direct Chromperfect toward the correct baseline region.
SBAV plus turns Set Baseline at all values on. SBAV minus turns it off and returns the method to automatic clustering. These events control baseline behavior across a region of the chromatogram. When SBAV plus is active, clustered peaks are broken at each valley, producing separate valley-to-valley baselines. This is useful when the automatic common baseline places grouped peaks over a baseline that is too low or otherwise unsuitable. Horizontal baselines. HORZ plus starts horizontal baselines. HORZ minus stops horizontal baselines. These events are used when a horizontal baseline is required over a defined region of the chromatogram.
A horizontal baseline can be useful where the natural baseline slope, or automatic baseline placement, is not appropriate for a particular group of peaks. HORZ plus is placed where the horizontal baseline behavior should begin. HORZ minus is placed where that behavior should end. Together, these events define the region where horizontal baseline handling applies. Peak width. PW plus increases peak width. PW minus decreases peak width. Peak width affects how Chromperfect detects peaks. If peaks are broader than expected, increasing the peak width can help the integration algorithm treat them correctly. If peaks are narrow and closely spaced, decreasing the peak width can help Chromperfect respond more appropriately to sharper peak features. These events are useful when peak width changes in different parts of the chromatogram.
Threshold and noise. TH plus increases the threshold. TH minus decreases the threshold. Threshold affects peak detection sensitivity. Increasing the threshold can help prevent noise or small disturbances from being detected as peaks. Decreasing the threshold can help detect smaller peaks that may otherwise be missed. These events are useful when different parts of the chromatogram have different noise levels or different detection requirements. MUT is a threshold-related event used to modify how threshold behavior is applied. It is a more specialized event, but the general purpose is still connected with controlling how Chromperfect distinguishes real peaks from background signal or noise. Negative peaks. NEG plus turns negative peak detection on. NEG minus turns negative peak detection off. Most chromatographic peaks are positive peaks, but some methods or detector responses may produce negative peaks. When negative peak detection is required, NEG plus tells Chromperfect to look for negative peaks. NEG minus turns that behavior off again. These events are useful where only part of the chromatogram contains negative peaks, or where negative peak detection should not be applied across the whole run. Peak splitting. Split splits a peak. This is a single event placed at the point where the split should occur. It is useful where Chromperfect detects a peak as one combined peak, but the user needs it treated as two separate peaks. Split is one of the events most directly related to peak boundaries and tick marks, because it tells Chromperfect where a peak should be divided. Peak summing. Sum plus starts a peak sum window. Sum minus stops a peak sum window. These events are used when several peaks should be treated together over a defined region. Sum plus marks the beginning of the region. Sum minus marks the end of the region. This can be useful where a group of related peaks should be reported or handled as a combined response. Cluster and combination events. Com plus turns combination behavior on. Com minus turns combination behavior off. These events are used where peaks or peak clusters need to be treated in a combined way over a defined section of the chromatogram. They are more specialized than a simple split or baseline event, but the principle is the same. Com plus starts the behavior, and com minus stops it. Skimming events. SKIM skims riders from the next peak. This is used when a smaller peak is riding on the side of a larger peak, and the integration needs to separate the rider peak response from the main peak. Skim plus turns automatic skimming on. Skim minus turns automatic skimming off. Skimming events are useful where shoulder peaks or rider peaks occur regularly, and the method needs to handle them consistently for a repeating chromatographic pattern. Skimming should normally be controlled through timed events, rather than repeated manual edits. Area reject. ARJ plus turns area reject on. ARJ minus turns area reject off. Area reject controls whether small peaks below a defined area threshold are rejected. This can be useful where part of a chromatogram contains small peaks
noise, or unimportant responses that should not be reported. ARJ plus starts the area reject behavior. ARJ minus stops it. Retention time labeling. RET plus turns retention time labeling on. RET minus turns retention time labeling off. These events control whether retention time labels are shown. They are display and reporting related, rather than core peak detection events. RET plus can be used where retention time labels should appear. RET minus can be used where they should be hidden. Selection events. SEL1 through SEL9 are selection events. SEL minus turns selection off. These events allow different selected regions or groups to be controlled within the method. They are useful where the method needs to apply selection behavior to specific parts of the chromatogram. For many users, these events will be less commonly used than baseline, split, integration, or skimming events, but they are available when method-specific selection control is required. Trace events. Clamp plus turns clamping on. Clamp minus turns clamping off. Clamping affects the chromatogram trace over a region. Flip plus turns flipping on. Flip minus turns flipping off. Flipping changes the direction of the trace response. These events are not normally the first events used for routine peak boundary correction, but they are useful where the trace itself needs to be modified for correct processing. Tigre relay events. The relay events are R10 and R1C through R80 and R8C. These events are different from the normal integration events because they are used for hardware relay control. In Chromperfect, relay timed events are associated with Tigre interfaces that include physical relay outputs. The letter O means open, the letter C means close. So, R10 opens relay 1 and R1C closes relay 1. The same pattern applies through relay 8. For example, a method could use a timed relay event to open or close a relay at a defined point during the run, depending on the connected Tigre hardware and how the system has been configured. These events should be thought of as hardware control events, not peak integration events. They are included in the timed event list, but they are not normally the events a user would choose when trying to adjust peak starts, peak stops, baselines, splitting, skimming, or tick marks. Choosing the right event. The easiest way to choose a timed event is to start with the problem you are trying to solve. If you want to ignore part of the chromatogram, use INT minus and INT plus. If you want to force a baseline point, use SBN. If you want the baseline set at the next valley, use SBNV. If you want a horizontal baseline over a region, use HORZ plus and HORZ minus. If a peak needs to be divided, use split. If peaks need to be summed, use sum plus and sum minus. If a rider peak needs skimming, use SKIM or the schema events. If peak detection sensitivity needs to change, look at PW, TH, MUT, and NEG. If the issue is mainly display or reporting, look at tick, points, RET, and cell. If the requirement is hardware relay control on a Tigre interface, use the relay open and close events for the appropriate relay number. Best practice. Timed events should be used carefully because they are part of the method. That is also what makes them powerful. A manual integration change is useful for one chromatogram. A timed event is used when the same integration behavior should apply automatically and consistently in future runs. When adjusting a method, it is good practice to make one change at a time, reintegrate the chromatogram, and confirm the result before adding more events. This makes it much easier to understand which event caused which change. Summary. Timed events are one of the main tools Chromperfect provides for repeatable, automated integration control. They allow integration behavior to be defined in the method instead of relying on repeated manual changes to individual chromatograms. In this video, we have introduced the main timed event groups, explained what each event is intended to do, and shown how they fit into a method-based integration workflow. The key point is simple. Use manual integration when you need to review or correct one chromatogram. Use timed events when you want the method to apply the same behavior automatically in future runs. Thank you for watching. Please like this video, leave a comment if you have a question, subscribe to the Chromperfect training channel, and visit chromperfect.com for more Chromperfect training and support resources.